So now we'll focus on machine learning itself. So machine learning is a way to write programs that accept to analyze data and auto-tunes their internal parameters to make good predictions automatically based on historical data. So typically, you try to have a program that finds the structure of the data, to find the relationship between input variable and output variable, so that when you have new data, you pass it as an input to that program, and it will predict the most likely output for that specific piece of data. So for instance, you can do time series forecasting for the price of an asset, or the temperature if you're doing weather forecasting, or spam or not spam in emails, and so on. So it's going to be more intuitive if we do some plots. So let's execute matplotlib and plot this function, which is already it's written as a external Python file that you can find in the zip folder if you want. So this function basically shows a data set in 2 dimensions. So the first dimension is on the x-axis, and the second dimension is on the y-axis. And those are the 2 input variables for our model. And the goal of this model is to separate blue dots, or gray bluish dots from orangish dots. And you can see that there is a natural organization in that 2-dimensional space. And so we can build a model that will draw a line, a boundary between those 2 areas. And we'll try to maximize the margin between those 2 areas. So in that case, it's using a stochastic gradient descent linear model. So it's trained with the stochastic gradient descent optimization routine to fit a linear model. And a linear model is just something that finds a hyperplane into that space of 2 dimensions. So it's a straight line in 2D. I won't detail the mathematics any more than that. I will just give you some names like this, and if you can have a look at the reference documentation on Scikit-learn website if you want to have more details on the mathematics of the models. And in the documentation, we also include references to the main papers in the literature to get more details. So does it make sense? So for instance, here the 2 variables could be the age and size of people, and half of the people could be men, and half of the other people could be women, and you could try to find a boundary based on the age and size information. It's completely stupid because in real life, men and women will have almost the same size and matching ages, so the 2 groups will overlap a lot. In this case, there is a clean separation. This is really very rarely the case in real life. Otherwise, we wouldn't need to do machine learning. All right. So let's move on. So if you are interested in the source code for this, you can execute this statement, and you see figure here is a folder that is also a Python package because there is an init file in it, and we import this function from there. And this is actually, this function is defined in that module. So it's just not very complicated to do that plot. You can see that there is the function itself, the scikit-learn classifier here that is fitted on the data. And then we do a bunch of matplotlib magic to generate the figure itself. We will see in detail how to train models. There is a second kind of machine learning algorithm that we will tackle during this session. Is called regression. So the first one was a classification problem because we had 2 categories of samples, and we wanted to find a boundary between those two categories. So it's classifying blue or orange. In that case, we will do a regression problem where we have 1 input variable on the x side and 1 output variable on the y axis. And in this case, we try to find a linear relationship between the output and the input. So you can see that the output is a continuous variable because there are many different possible values of y. There is not just 2 or a finite number. It's a floating point values. So basically, regression is when you do machine learning and the target variable that you're trying to predict is a floating point number. It's a continuous variable. Classification is the same, but you're trying to assign finite number of classes to the output. So discrete variables, so integers or string labels. All right. So to do machine learning in Python, you can use the Scikit-learn project. So it's an open source project. You can download it, and it works on most platforms. So if you go on scikitlearn.org, you have the full documentation. And if you import scikit-learn, you can play with examples data sets that are shipped into the library directly, which is very nice to quickly explore the behavior of models on sample data. So this is mostly toy data because it's small, so that you can download it quickly. But it's already useful to get some intuitions. So in the dataset package of scikit-learn, there is a function called load digits that returns an object that has several attributes: data, target, and images, and many more. So data, so let me execute that. So data is a NumPy array, and you can see that it's a two-dimensional NumPy array. If I do shape here, I see the shape of the array. So it has more than almost 2,000 rows and 64 columns. So we call the rows the samples and the columns the features. I'll give more details on what it means. But the input data of most scikit-learn models will be expected to have a two-dimensional shape with samples and features. And we also have a target variable that is stored in a separate array, which is a one-dimensional array. And you can see in that case, those are not floating point values, but those are integers. I can check the D type. And integer, 64 integer. So those integers are basically the labels for each of the rows in my data set. So why do you think there are 64 values in those rows? You have an intuition on why 64?
8 by 8.
Yeah, 64 is 8 by 8. And those are actually pictures represented as rows in a NumPy array. And they are just pixel values, gray level pixel values of 8 by 8. So we can check that by accessing the images attribute, which has the same data but shaped in a different manner. So if I check the shape, you can see that I have the same number of rows, but then I have 2 dimensions. After that, it's a 3-dimensional array, and I have 8 by 8. So if I take the first row of that 3-dimensional matrix, I get an 8 by 8 array, and on this 2-dimensional array, I can do imshow with cmap equals plt.cm.gray. And I can see, I can visualize my metrics. I will also do interpolation equals nearest, because otherwise it's slightly misleading. So you can see the actual data. Those arrays are actual images, and they are gray level images with pixel values. So you can see that I have just 8 by 8 pixels, so 64 in total. And those are gray level values between 0 and 1, I think. 1 is white, and 0 is black. Okay? So the digits.data attribute is the same but reshaped. So the first row will be concatenated with the second row, and so on a single 64-bit vector, a 64 value items vector. Okay? So now we have the data. We can train a model. So to train a model in scikit-learn, you import, you read the documentation and you see the list of modules, and you find the modules that you're interested in. And so in that case, we are looking at the SVC class from the SVM package. So the SVC class stands for support vector classifier. So it's a support vector machine for classification and not regression. So discrete target variable. And it takes two input parameters, which we call hyperparameters. Those are mathematical constraints that will affect the way the machine learning algorithm will learn from the data. So those values, here I'm fixing them arbitrarily, but in practice it's very important to try on the data which value works best. And we need to automate this using what we call the parameter sweep or grid search when we want to do that in real life. For now, to start, we will just fix those two values. So I created the CLF object, which is classifier. So by default, it's untrained, and if you print it, you see all the default parameter values for that model. So some of them are like mathematical attributes that constrain the machine learning algorithm, like coef and degree and gamma. And others are more like technical attributes, like whether we print stuff on the output, the cache size, the in-memory cache size of the object. So you have to read the documentation on the website to understand what they mean. So once we have our instance, our object, we can call the fit method on the data. So in this case, I will just take all the elements of the data set except the last one, columns dash minus one. Column dash one means all the elements except the last one, and I do that both for the input, so all but the last row, and the output, all but the last variable. And this will train internally the model. So it's exactly the same object, but it has been mutated internally to fit its internal parameter to compress the data and find the structure of the data. Once I have this, I can call predict on the last row of my data set, and it outputs a single integer, which is the integer matching the class of that data set. So we can have a look at the last image of the data set and use imshow again. And you can see that the last data point that we used for the prediction is this. And it predicted 8. So it looks like an 8. So apparently it did a good job in that case. So we can check by printing the target value, the value of the target variable for the last element. It's actually an 8, so it's a good prediction. All right. So do you have questions on this? No? Let's move on. So you can close this notebook and go to the next one. We will re-explain in a bit more detail how the data works in Scikit-learn. So as you've seen, we've dealt with NumPy arrays for the input variable that has 2 dimensions. The first dimension is called the sample. The second dimension is the features. So the samples are the observations or the instances in your data set. The features are the attributes of each instance. So you can also visualize this as a database table, a SQL database table, or an Excel spreadsheet, for instance. You have columns and rows. In general, the convention is to put on the columns attributes of observations and individual records as rows or samples. So this is the traditional way, and this is the representation that Scikit-learn expects for all the algorithm. So we can load another data set, which is a data set that was built by having like biologists moving around in the nature and looking for flowers like this one. So the species of this flower is an Eris setosa. but they are like very close species, versicolor and virginica. And so the biologist wants to classify those flowers. And to do so, they will observe numerical attributes of those flowers to be able to build a classifier. So in your opinion, what kind of attributes can we collect on those pictures to try and classify them? The color, yeah. Yeah, and so if you're a statistician, you know that it's interesting to measure the petal length, the petal width, the sepal length, and the sepal width. So I'm not a biologist myself, so I don't know which one is the sepal and which one is the petal. But if you're a biologist, you would do. And so in that case, we have this data set, which is a classical data set for statistics. And so it's loaded, it's available as a CSV file that we can load from Scikit-learn, and it has 4 attributes, so 4 columns, sepal length in centimeters, sepal width, petal length, petal width. And we have 3 target variables, which are the identifiers for the 3 species. So again, we can import this data set from the dataset folder in Scikit-learn. And see this object here, iris. It's a weird kind of object that looks like a Python dictionary. So it has different keys or attributes. So we have the data array, the names of the features, the target variable, and the names of the targets. So let's have a look at the data array. We can load the shape and print the first element. So we have 150 flowers. We have the 4 attributes for each individual flower. And so in the first flower in my data set, I have a petal length, I think. No, sepal length, sepal width, petal length, petal width. So apparently the sepal are bigger than the petal on these flowers. So this is the input data, and we also have a target variable. And you can, it's a good sanity check when you're dealing with data like this and you want to do a machine learning, to check that the target variable, you have as many observations in the target variable as you have in the input data, because otherwise you have a mismatch and it means that it's not actually the right labels. And we can have a look at the target variable arrays, and you can see that I have 150 elements, and they have 3 possible values, 0, 1, or 2. And to understand the meaning of those 3 values, you can have a look at this target names attributes, and 0 stands for setosa, 1 stands for versicolor, and 2 for virginica. So in scikit-learn for classification, we often use integer encoding for the different possible classes. It's because it's more efficient from a memory point of view than repeating the string values over and over again. So we use numerical encodings like integers. So let's plot 2 dimensions of this data set. So here I'm selecting the first 2 dimensions, so sepal length and sepal width on those 2 axes. And I'm using matplotlib to do a scatter plot with different colors for the 3 possible species. And you can see already that the setosa species, for instance, just by having a look at the sepals, it's quite easy to separate them from the other 2. So let's try to play with this cell by changing the values of the indexes. So you can see that those are the indexes of the columns of the data frame, the data array. So let's try to use other attributes and look for a better separation between the 3 classes. And do that on your computer and see if you can find better ways. Actually, all the ones I've tried already. afraid of that.
Yes. Now you have that. Like,
I'm on-
Ben is not saying it.
Hopefully the video is still fine.
Yeah.
Okay, thanks. All right. So do you have any suggestion? 1 to 2, actually. This is the one that I printed. And it's actually a good suggestion because you can see that it would be easy to draw a line here to separate Cetesa versus versicolor. Drawing another line here would work quite well. So it means that if we select a subset of the features, the right subset, we can actually have a good model. What we did there is just manual feature selection. In real life, we will not do that. We will give all the features to the algorithm, and most of the time the algorithm should be able to pick up and weight the feature relatively to one another to find the good ones. So the question is, can you plot a third dimension? It's possible with Matplotlib to do 3D plots, but it's a different syntax. I don't remember it. But most of the time, anyway, 3D plots, you have like matching dots everywhere, so it's not really visible. So, but you could if you want. And anyway, in that case, it's 4-dimensional data, so it's limited. And in real life problems, you would have hundreds or thousands of dimensions anyway, so there is not much problem. So another question?
Can you please explain this function formatter?
Okay, so the question is, can you explain this function formatter? So basically, this is a trick. Yeah, no, I cannot explain this. Yeah, it's Galvaroco's Matplotlib stuff. I wouldn't have done it myself this way, so I think if you want to, you can call several times PLT scatter with different subset of the data and assign explicit color to each of them and put a label and call the legend. It would have been easier to understand, but slightly longer to type. Okay, but you can, if you want to know how to do Matplotlib's visualization, the best way to do it is to go to the Matplotlib website. There is a gallery. You look at the plots that looks like the one that you're interested in, and you adapt the source code to fit your data. All right. So in scikit-learn, there are many other available data sets. So if you import the datasets package, you have functions that starts with underscore, fetch, or make. Load underscore is for loading data that is shipped within the source code of scikit-learn. So those are very small data sets. Other more realistic data set can be downloaded from public URLs on the web. So you can use fetch data, and it will download the original data and convert it into a NumPy array for you and save it a local copy in a temporary folder in scikit-learn. And finally, you have also make, which is useful for generating synthetic data with statistical assumptions that you make over the data to just try to break your machine learning algorithm using statistically generated data. So let's try to have a look at the kind of data sets that you can load. I forgot to import, I think. Yeah. I forgot to execute this cell. Okay, so if I do a load underscore and I hit the tab key, IPython will autocomplete. So you can see a bunch of standard data sets, like Boston is for regression of housing prices in Boston in the 70s. There you have the digits data set, diabetes, and so on. If you want to know where those data come from, I just want to do that. No, actually, get rid of that cell. So if you want to know where those data come from, and actually when you fetch data, it will store them in a local folder. And to know where this folder is, you can call get data home from the dataset package, and you will see the path to your local folder on your machine, on your hard drive. Yes?
How did you have that count?
So you need tab completion. So you do data sets, you can hit tabs in complete, and you type the beginning of something, and you tap the tab key again. So this will work on my machine because I have the home environment variable set up, and it's a bash command. But what you can do is copy and paste this guy. And do a dir or ls. And you should see the temporary files that are downloaded by scikit-learn when you fetch dataset. So don't fetch any dataset now because it's going to be too slow. But in the future, if you use the fetch commands, it will download them all here. Okay? Okay, so let's play again with the digits dataset. Actually, we can move on a bit and skip the end of this and move on to the next one because we're already. So actually, we can break now, and we'll do the next one in the afternoon.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.